Greetings everyone. My name is Shivangi Yadav and I'm a PhD student at Michigan State University in the guidance of Dr. Arun Ross. Today I'll be presenting my work where we have designed a new image-to-image translation technique, CIT-GAN, or Cyclic Image Translation Generative Adversarial Network with application in iris presentation attack detection. Before moving on to the presentation, I would like to go over some important terms that I'll be using frequently. Biometrics is automated human recognition using traits such as fingerprint, face, iris, etc. Human recognition using biometric traits can be hindered using presentation attacks that refer to physical artifacts, which can be used to either obfuscate or impersonate someone's identity or create a virtual identity altogether. And presentation attack detection methods aim to detect these kind of attacks. In the presentation, synthetic images refer to images generated using a generative adversarial network or GAN, and real images refer to original data with no alterations. This can be either bona fide or PA. Now, the goal of this research is that most presentation attack detection algorithms are binary classifiers that depend on data from both classes bona fide and PA, which creates the dependency on sufficient number of samples from each class for training and good performance. In this research, our aim is to develop a method that has capability to learn style characteristics of different PA classes and use them to synthesize good quality PA samples for training. Therefore, in this research, we propose a method that provides a good mechanism to synthesize good quality data for PA classes that are hard to acquire. In the proposed method, we want to translate bona fide images or the source images that are sufficiently available into different PA styles using the style characteristics of the reference images as shown in this figure. We achieve this using generative adversarial network with a styling network in the proposed method known as Cyclic Image Translation Generative Adversarial Network or CIT-GAN. Here the generator and discriminator is different from standard GAN methods in order to incorporate image translation and scalability to multiple domains. Generator takes as input an image and translates it to target domain using style characteristics of reference or target PA from styling network. The styling network, as shown in green over here, extract the style code from a given reference image and use that as domain style information in the generator. In the multi-domain style transfer, unlike standard GAN, discriminator decides for each domain whether the given image is real or synthetic. Now finally, to guarantee that the generated images properly preserves the domain invariant characteristics of its input image, we employ the cycle consistency loss. Some example of the translation in trained network from bona fide to PAs are given in this figure, where network takes in bona fide images as input and using reference images as shown over here, translate them to different PAs. We synthesized 8,000 samples for each PA class for analysis and got a Fletcher inception distance score of 32.79. This is a distance score that analyzes statistics of synthesized data with respect to real data. So lower the FID score, better it is. To better understand the FID score we achieved, we compared it with the state-of-the-art multi-domain style transfer method CIT-GAN version 2. Above histogram compare the FID score distribution of synthetically generated PA samples of proposed method CIT-GAN with that of CIT-GAN version 2. FID scores for CIT-GAN generated images are lower than CIT-GAN version 2, which shows that proposed method generates better quality data than CIT-GAN version 2. We further did some experiments with current state-of-the-art methods to analyze the efficiency of synthesized PA images in replacing real PAs. Experiment 1 is the baseline experiment that demonstrates the performance of current iris pad methods on current iris PA datasets with imbalanced samples. Experiment 2 and 3 are two different experiments that evaluate the performance of pad methods when real PAs are substituted with synthesized PAs. And finally, experiment 4 showcases the benefit of training pad methods with balanced PA classes. Now, looking at the performance of the state-of-the-art DNetPad, you can see that a marginal variation in performance is observed when real samples are substituted with synthetically generated samples. Also, experiment 4 shows improved performance with respect to baseline, emphasizing the importance of training with balanced PA samples. In conclusion, we designed a novel multi-domain image translation method, CIT-GAN, that can synthetically generate images across multiple iris presentation attack domains with multiple uses. For future work, we would like to extend this work to generate PA samples with different variations of variations and multi-domain style, which will potentially allow current iris pad methods to generalize over different styles of PAs. Thank you.